We present to you our project is self-service thermometer.
Since COVID-19 has become Malaysia's most concerned matter, temperature screening has become a common practice at medical facilities, workplace, and even shopping mall. A fever is one of the more immediately identifiable symptoms of infection, so thermometers are a key defensive tool in fight against the highly contagious virus. The Ministry of Health even recommends that all employers should have their staff take temperature at least twice daily. As the COVID-19 pandemic worsens, contact with other people should be minimized. Self-service thermometer is the thermometer that used to take temperature without having contact to another person. For this MEC 532 project, this problem will be solved by using self-service thermometer that will build using Thinkercad as simulation on how machine conduct its function. This self-service machine also will record on how many people use this machine and how many people has been suspected for this virus. Public places like shopping malls, supermarket, and workplace are packed with people from different background and history. During this world pandemic, COVID-19 is primarily transmitted from symptomatic people to others who are in close contact through respiratory droplets, by direct contacts with infected person, or by contact with contaminated objects and surfaces. As we know, the most common symptom of this virus is fever. In order to prevent the virus from widely spread, since public places are always full of crowd, this can be done by build or provide a machine that can detect body temperature without having contact to another person. Self-service thermometer has been introduced to detect if they have been infected or been suspected by this virus. This self-service thermometer will detect body temperature, as this machine will be set if 37.5 Celsius and above, people prohibited to enter this place, and this machine will give signal in red light, also will give beep sound to know if they have been suspected.
As for objective, our main concern is to detect people with temperature of 37.5 degrees Celsius and above, and it's linked to fever. Self-service thermometer can help to ensure the health of people around, as well as to avoid people from entering public places if they have this symptom. Not only that, one of our main reasons to come out with self-service thermometer is to end the spread of infection and promote a healthy work environment.
So, these are the list and also the quantity that we use in our mini project, which is self-service thermometer. The component consists of Arduino Uno, resistor, LCD, piezo buzzer, jumper, potentiometer, LED, small breadboard, and also temperature sensor. For Arduino Uno, is the programmable board that used to build interactive circuit. Next, for resistor, is used to restrict flow of electricity in a circuit and also can reduce voltage and current. For piezo buzzer, is the type of buzzer that produce sound at different frequency. For LCD, is used to display temperature reading. Next, for potentiometer, is the type of resistor whose resistance change at the turn knob. For LED, it will light up when electricity passes through it. For small breadboard, is used to correct the circuit and component. And for the last component is temperature sensor, which is it will send the output voltage based on the ambient temperature. After we finalize the component, the total cost of component for our mini project, which is self-service thermometer, is RM45.87, and we get this all component from Saturn Marketplace by online purchase. These are the circuit of self-service thermometer. Figure 1 shows our circuit of self-service thermometer that we create using Thinkercad software. The circuit shows the LCD will show the value of temperature, and this LED will give signal either red or green light. The buzzer will give beep sound if the temperature is above 37.5 degrees Celsius.
Hey guys, and today I'm gonna show you the demonstrations of our project. There is a self-service thermometer. So first thing first, you need to log in into your Thinkercad account, or if you haven't got any, you need to sign up for your account. So you can create a new circuit to start your project. After that, you choose the components that you need for the project. From the library, I choose 2 LED, green for the good condition and red for the warning indicator. Then piezo buzzer, 3 this component comes with 3 resistor. Then you can choose your Arduino starter, run with the LCD. Then I search for the temperature sensor for our project. Is TMP36 temperature sensor, TMP36. Then after you complete searching for your components, then you can start to assemble or arrange the components to the breadboard. After that, you can start to connect each components with the breadboard and also with the Arduino Uno. So as you can see, the red wire for the power source and the black wire for the ground source. So for the LED, we connect with the digital pin number 9 for the green one. Then we connect the red one with the digital pin number. The LCD Arduino starter comes with the code. As you can read, you can delete the code that you not required for the project, and you can start to declare your constant integer. It's basically for your LCD connection with the Arduino. So as you can see, RS connect to the digital pin number 12, EN to the digital pin number 11, and so on. Then you can start to declare your integer baseline temperature equal to 0, where the 0 is analog input 0, integer Celsius also analog input 0, then float Celsius data also same. And you can start to declare your integer alarm, that is piezo buzzer, connect with the digital pin number 7, integer temp pin temperature, then float temp data to the analog input 0. So for integer LED 1 or red, we connect with digital pin number 10, and for the LED all good or green LED, we connect with digital pin number 9. Then we proceed for the void setup. We set the functions, that is pin mode for the input and for the output. For the input, we take the analog 0. For the output, we take the digital pin number 9 and 10. Proceed with the void loop. In this void loop, the functions will keep repeating until certain conditions that we set in the coding is achieved. So in this void loop, we set the baseline temperature, that is fever temperature is 37.5 degrees Celsius. For this project, I will use the if-else statement. For the condition of the if statement, if the Celsius value that we detect from the temperature is bigger than the baseline temperature, that is 37.5, so it will execute the if statement. So we start to declare the temp data, the digital write for the alarm read as high, digital write for the LED one, read as high. Also, digital write for the LED all good, read as low. For the height means the components will switch on. For the low conditions means it will switch off. Then you can see from the LCD it shows fever detected. Then it will shows the danger sign. So for these conditions, it will trigger the alarm or piezo buzzer, and also the red LED will turn to red. While for the LED all good or green LED will stay off. Proceed with the else statements. The conditions is against the condition in if statement, where the condition is good. This means the temperature is below 37.5. So you can see the digital write for the alarm and LED one is low, while for the LED all good is high. Basically, this means the piezo buzzer and also red LED will not trigger in these conditions, while for the green LED it will switch on. So as you can see from the LCD, it will show the temperature detector sign, and it will show the value of the temperatures in Celsius. So we can start our simulation. So check the error. So there's an error, we can fix that, then we try again. Our project is running great, thank you. So this is 3D model for our project, self-service thermometer, front view and also the side view of the model.
This mini project is created by Muhammad Fadil bin Muhammad Jafar, Nur Atira binti Azman, and Siti Nurul Aliza binti Shahrudin.